Anhydrous barium peroxide does not react with sulfuric acid because a coating of insoluble barium sulfate was formed. Whatever the dilute hydrogen peroxide has been taken from the preparation, that will be kept in water bath, which will be around 50%, and it will increased by the slow evaporation. Due to some oxidation or something, white lead sulfate will turn to black lead sulfate. It will be reversed by using hydrogen peroxide. Hello everyone, this is Harshita Bhavasar from Vidyashram School of Excellence. Today we are starting up session 4 from the chapter Hydrogen. In the last class, we have discussed about water, that is how the structure of water will be present in gaseous state, liquid state as well as in a solid state, and what are the concepts or what are the properties which will affect for the three states of matter according to its structure, that also we have discussed, and physical properties of water and chemical properties of water also we have discussed in the previous session. Next, in this session we will discuss about hydrogen peroxide, physical and chemical properties of hydrogen peroxide and heavy water. Hydrogen peroxide, its molecular formula is H2O2. 2 atoms of hydrogen, 2 atoms of oxygen, was discovered by French chemist called Thenard. Okay, H2O2 is called as hydrogen peroxide, and how it will be prepared? Preparation from barium peroxide. Hydrogen peroxide is prepared by the action of sulfuric acid or phosphoric acid on hydrated barium peroxide. When we will tell hydrated, if it is present after dot H2O, any molecules of H2O, that will be considered as hydrated. Hydrated barium peroxide is treating with or reacting with aqueous sulfuric acid. It will form barium sulfate. After that, it will form H2SO4 plus 8H2O. It is in between as an intermediate. Hydrolysis of peroxy disulfate obtained by electrolytic oxidation of acidified sulfate solutions at high current density gives hydrogen peroxide. Means hydrolysis of peroxo disulfate, if it is going with or if it is subjected with electrolysis, it will form intermediate called acidified sulfate solutions, and when it is hydrolysis takes place, that hydrogen peroxide will form. This hydrogen peroxide will form when hydrolysis will takes place. This method is used for the laboratory preparations of D2O2, that is nothing but hydrogen peroxide, potassium sulfate and these two molecules of deuterium oxide, it will form D2O2 in the laboratory called hydrogen peroxide. In industrially, H2O2 is prepared by the auto-oxidation of 2 alkyl anthraquinols. Auto-oxidation means self-oxidation by 2 alkyl anthraquinols. Here 2-ethyl anthraquinol oxidation takes place in the presence of palladium catalyst. See here, O2, this is oxidized, H2O2 will prepare plus oxidized product. Some oxidized product will be formed, but what we require the main product, hydrogen peroxide. How it will form? From 2-ethyl anthraquinol got self-oxidized, like auto-oxidized to form hydrogen peroxide. Anhydrous barium peroxide does not react readily with sulfuric acid because a coating of insoluble barium sulfate is formed on its surface, which stops further action of the acid. Anhydrous barium peroxide does not react with sulfuric acid because a coating of insoluble barium sulfate was formed. So, which stops further action of acid, therefore hydrated barium peroxide must be used. In the previous reaction we have seen that when barium peroxide was used, treated with hydrosulfuric acid, that time it stopped for barium sulfate because a coating of barium sulfate was present. That time stopped the reaction of or the action of acid, and whenever the barium peroxide was used, the complete reaction was undertaken. Barium oxide, this is phosphoric acid, this will form barium phosphate plus H2O2, that is hydrogen peroxide. When barium phosphate is treated with sulfuric acid, barium sulfate will form with phosphoric acid. H3PO4 is phosphoric acid. Phosphoric acid is preferred to H2SO4 because soluble impurities like barium persulfate tends to decompose as H2O2 while H2PO4 act as a preservative for H2O2. They prefer that more than sulfuric acid, phosphoric acid should be used because soluble impurities like barium persulfate tends to decompose H2O2. Okay. And H3PO4 will act as a preservative. Is a negative catalyst. Next one, concentration of hydrogen peroxide. How it will be concentrated, how it will be used. Dilute H2O2 is concentrated to about 50% by slow evaporation on a water bath. Whatever the dilute hydrogen peroxide has been taken from the preparation, that will be kept in water bath, which will be around 50%, and it will increased by the slow evaporation. It is further concentrated to 90% in a vacuum desiccator using a concentrated H2SO4 as a dehydrating agent. Whatever the 50% hydrogen peroxide is present, now it will be converted into 90%. How it will be converted into 90%? That whatever the 50% is present, it will be kept in vacuum desiccator and H2SO4 will be added. That H2SO4 will be act as dehydrating agent. What is the dehydrating agent or dehydration? Removal of water molecule. If we remove the water molecule from the dilute solution of any dilute solution, it will become concentrated solution. Next, volume strength of hydrogen peroxide. H2O2 is miscible with water in all the proportions and forms a hydrate. What they are telling, how the volume strength of hydrogen peroxide is there. Hydrogen peroxide, whatever the ml or whatever the volume if you take, that will be miscible with water and it will form hydrate. A 30% solution of hydrogen peroxide is marked as 100 volume. Hydrogen peroxide, it means that 1 millimeter of 30% H2O2 solution will give 100 volume of oxygen at STP. What they are telling, 30% of solution only will be considered as 100 volume of that solution. Why means that 30% is only will increase for 1 millimeter for a 100 ml volume of water. That is a standard temperature and pressure. Commercially, it is marketed as 10 volume, which means it contains 3% of hydrogen peroxide. Usually in the laboratories, what we will use the hydrogen peroxide, it will be around 3% of hydrogen peroxide it contains. Not complete hydrogen peroxide will be there. Next, how to calculate the strength of 10 volume of solution hydrogen peroxide, we'll see with an illustration. Calculate the strength of 10 volume of solution of hydrogen peroxide. Solution, 10 volume of solution of hydrogen peroxide means that 1 liter of this hydrogen peroxide solution will give 10 liter of oxygen at STP, that is standard temperature and pressure. This is hydrogen peroxide gives oxygen and water molecule. 2 into 34 will gives to 22 to 7 liter at standard temperature and pressure. It will give 68 gram. On the basis of above equation, 22.7 liter of oxygen is produced from 68 gram of H2O2 at STP. 10 liter of oxygen is at STP is produced from 68 into 10 by 22.7 gives gram of 29.9 gram, that is 30 gram of hydrogen peroxide. Therefore, strength of hydrogen peroxide in 10 volume, that is H2O2 solution, is 30 gram per liter, that is 3% of hydrogen peroxide solution will be present. This is the very important reaction to illustrate how much strength of hydrogen peroxide is present in 10 volume of solution. So, it shows 3% of H2O2 solution is present or 30 gram per liter is present. Next one, structure of H2O2. Hydrogen peroxide is non-linear, non-planar molecule. It is not in linear structure and it is not a planar also. It has a open book structure. If you see this structure, it shows a open book and the O-O linkage is called peroxy linkage. This is one oxygen, this is one oxygen. Here also it will be considered as peroxy linkage. The structure is shown in below. In gas phase, this is in solid phase. Little bit changes you can observe here. Bond angle of 111.5 degree, here 90.2 degree. Here 147.5 picometer, here 148.8 picometer, here 94.8, here 101.9, and 95 picometer, here 98.8 picometer. This is in gas phase, this is in solid phase. Little bit bond angles are changed. But overall this is open book structure. This oxygen and oxygen linkage will be called it as peroxy linkage. Next, chemical properties. Oxidizing nature. It is a powerful oxidizing agent. It acts as an oxidizing agent in neutral, acidic or alkaline medium. It is a very good oxidizing agent and it will act in alkaline also, in acidic also, in neutral medium also. Example, hydrogen peroxide oxidizes lead sulfide to lead sulfate in acidic medium. This is lead sulfide, and in the presence of hydrogen peroxide, it forms lead sulfate and water molecule. It is in acidic medium. Reducing nature. Hydrogen peroxide has tendency to take up oxygen from strong oxidizing agents and thus act as a reducing agent. Here, hydrogen peroxide will treating as reducing agent with water and oxygen. How? It is removing the oxygen from peroxide. Hydrogen peroxide reduces acidified permanganate ion to Mn2+, that is manganese. See here, manganese oxide plus hydrogen and plus hydrogen peroxide, it is going to reduce us. It forms manganese and water plus 5 molecules of oxygen. It reduced. Hydrogen peroxide reduces iodine to iodide in basic medium. Iodine to iodide. Okay. In the presence of that hydrogen peroxide. It will act as in neutral medium, in basic medium, also in acidic medium. Next, storage of hydrogen peroxide, how it will be stored. Hydrogen peroxide decomposes slowly on exposure to light and the alkali metal oxidizes present in glass catalyze its decomposition. Means hydrogen peroxide decomposes slowly on the exposure of light or any sunlight. So, it cannot be kept in glass also. The glass will also forms the decomposition. Therefore, H2O2 is not in stored glass bottles, hence it is stored in paraffin wax coated or Teflon bottles in dark. It starts decomposition if you keep in glass also. So, you have to store the H2O2 in paraffin wax dark bottles, that is black bottles. Small amounts of urea, glycerol, alcohol, acetanilide or phosphoric acid are glass. Plastic often used as stabilizers to be decrease its rate of decomposition. It is kept away from dust because dust can include explosive decomposition of the compound. It should not keep it in the dust area also because it is also starts decomposition as a induced explosive decomposition. Next, uses of hydrogen peroxide. Hydrogen peroxide has a various uses in the laboratories or the synthetic labs. For bleaching delicate articles like wool, hair, feather, ivory, etc. For bleaching purpose, to these kinds or to these substances it is used. For restoring color of old lead paintings whose white lead has blackened due to the formation of lead sulfate by H2S of atmosphere, hydrogen peroxide converts the black lead sulfate to white lead sulfate. Due to some oxidation or something, white lead sulfate will turn to black lead sulfate. It will be reversed by using hydrogen peroxide. As an aerating agent in production of sponge rubber, aerating agent. As an antiseptic and germicide for washing wounds, teeth and ears under the name of perhydrol. It is an antiseptic agent in ear and wounds or teeth also. In the manufacture of sodium perborate and sodium percarbonate, these are used in high quality detergents. In the manufacture of these chemicals which are used in laboratories and also used as high quality detergents, for the manufacture of these compounds, hydrogen peroxide is used. And it will be used as anti-chlor. It will be act as anti-chlor means it removes the chlorine from any of the substance or it will act as a bleaching substance. So, it will be used as an anti-chlor. Act as an oxidant for rocket fuel. In the detection of titanium, vanadium and chromium ions with which forms peroxides in the characteristics colors, like a qualitative analysis also. To detection of titanium, vanadium and chromium ions, it will be used. In the production of epoxides, propylene oxide and polyurethanes, also it will be used. In the synthesis of hydroquinone, pharmaceuticals and food products like tartaric acid. For pollution control of domestic effluents, where it restores the aerobic conditions of sewage waste. For pollution control of industrial effluents containing cyanide ions, and also hydrogen oxidizes cyanide ions into harmless products. This is a major advantage of the hydrogen peroxide. Next is heavy water. Heavy water is prepared either by prolonged electrolysis or by fractional distillation of ordinary water as by a byproduct in some fertilizer industries. Heavy water, what is heavy water means? It will be prepared by prolonged electrolysis. Uses of heavy water, it is extensively used as moderator in the nuclear reactors and in exchange reactions for the study of reaction mechanisms. Usually it will be used as moderator in nuclear power plants. For the preparation of deuterium, heavy water produces deuterium on electrolysis or by decomposition with metals. Deuterium is nothing but isotope of an hydrogen. Heavy water is used as a tracer compound of studying various reaction mechanisms. It has also been used for studying the structure of some oxyacids of phosphorus, that is phosphoric acid and oxyphosphorus, to determine the number of ionizable hydrogen atoms. It is used in the preparation of other deuterium compounds also. This is calcium carbide with deuterium oxide. This is dicalcium dideuterium plus calcium hydroxide will form. This is sulfur dioxide and deuterium oxide will form deuterium sulfate, and it will form calcium deuterium here, and aluminium trioxide also it will form trihydroxide. Next, hydrogen as a fuel. Hydrogen is being aggressively explored as a fuel for passenger vehicles. It is used as fuel. It can be releases large quantities of heat on combustion. Due to this point, it will liberate large amount of energy. For that reason only combustion will take place and it will be used as fuel. It is an environmentally friendly fuel that has the potential to used in the fuel cells, power electric motors burnt in the internal combustion engine. Here one advantage is there, it does not give much pollution level like other vehicles or other engines are giving out. This is because dihydrogen reduces our dependency on imported oil. It is also used in the propulsion of spacecraft and can potentially be mass produced and commercialized for passenger vehicles and aircraft. But several significant challenges must be overcome before it can be widely used. This completes your hydrogen chapter. I hope you have understood completely whatever I have taught. We'll meet in the next chapter. Thank you.